All right, today we're going to tackle a really critical piece of modern system design, something that brings order to the wild world of microservices, the API gateway. So let's dive right in. So why do we even need one of these things? To really get why an API gateway is so important, we first have to understand the problem it's built to solve. Let's take a look at what happens when you don't have one.
Now, if you're a developer who's ever worked with microservices, I bet this question hits a little too close to home, right? You've built all these amazing separate services, but how on earth do your users, your clients, actually talk to them all?
Yeah, without a gateway, this is the world you're living in. Your mobile app or your web front end has to know the exact address of every single microservice. It creates this tangled web that tightly couples your client to your backend. And worse, you find yourself writing the same boring off code, the same error handling over and over in every single service. It's a mess. It's brittle and it's super inefficient.
Okay, so how do we fix this? How do we clean up this maze and bring some sanity back into our architecture? Well, it's time to hire a receptionist for our system.
And that receptionist has a fancy job title, the API Gateway. Basically, its entire job is to be the one and only front door for your whole application. Every single request from a client goes to the gateway first, and the gateway is responsible for figuring out where it needs to go next.
And honestly, this receptionist analogy, it's the absolute best way to think about it. You wouldn't just barge into a giant corporate headquarters and start wandering around looking for the finance team. No way. You go to the front desk and they tell you, finance is on the third floor, room 302. That's exactly what the API gateway does for your code.
So what does this receptionist actually do all day? I mean, it's got to be more than just pointing traffic, right? Oh, yeah, it has some serious superpowers. Let's break them down. Okay, this is probably its most important job, for real. Think about it. All these things on the list, authentication, rate limiting, logging, almost every single one of your services needs to worry about them. Instead of building that logic into every service, you do it once, right at the gateway. By handling it all in one place, your microservices get to be lean, clean, and just focus on what they're actually supposed to be doing, their business logic. All right, let's get practical and talk about efficiency. Picture this, you're building a product page for an e-commerce website. Without a gateway, the app on your phone has to make one network call to get the product details, then a second call to check inventory, and then a third call to pull down the reviews. That's 3 separate network requests. It's slow, it's chatty, and it's a battery killer. And this is the solution. It's a really cool pattern called API composition or API aggregation. With a gateway, the client makes just one simple request. Then, the gateway does all the heavy lifting. It gets that one request, and then it goes and talks to all 3 internal services. And it can even do it at the same time. It then stitches all that data together into a single, clean response. So much better for the client.
And of course, we can't forget its most basic job, right? At its very heart, a gateway is a router. It just looks at the incoming request and its URL and goes, oh, /API/users, that goes to the user service. A post to /API/orders, yep, that's for the order service. It's the smart traffic controller for the entire system.
Okay, let's pause here for a second and clear up something that trips up a lot of people. You hear it sits in front of servers and directs traffic, and your brain immediately jumps to load balancer, right? Well, they're similar, but they are definitely not the same thing. Here's the absolute key difference, the one thing you need to remember. A load balancer sends traffic to identical copies of the same service. Its job is to handle scale and reliability. An API gateway, on the other hand, sends traffic to completely different services. Its job is smart routing based on the request itself. It's way smarter because it works at layer 7, the application layer. It can actually look inside the request to make decisions. But here's the cool part. They're not enemies. They're actually best friends. They work together. In any real-world, production-grade system, this is what you'll see. A client talks to a load balancer, which then spreads the traffic across multiple identical instances of your API gateway. This makes your front door both scalable and highly available. Okay, so this all sounds amazing, right? But any senior engineer will tell you there's no such thing as a free lunch in system design. When you add an API gateway, you're also adding a new piece of infrastructure that has its own risks and trade-offs.
The trick isn't to pretend these problems don't exist, it's to know about them and plan for them. First, the single point of failure. I mean, if all traffic goes through one door and that door gets stuck, your whole app is down. That's exactly why you always run multiple gateway instances behind a load balancer. Second, it can be a bottleneck. Since every request goes through it, it has to be incredibly fast and scalable. And finally, you have to be careful it doesn't just become a new monolith, a place where every team has to fight to get their changes in. So why are we getting into all this nitty-gritty detail? Well, it's not just about building better systems. It's about being able to prove you can build better systems when it really matters, like in that next big system design interview. All right, so if you get that dreaded design a microservices system question, here's your cheat sheet. These are the 5 points you absolutely have to hit. Start with the why, talk about centralizing those cross-cutting concerns, and definitely show you know the difference between a gateway and a load balancer. Don't forget to mention API composition. That one shows you're thinking about performance. And finally, acknowledge the risks. It proves you're a well-rounded engineer. And that just about wraps it up for our deep dive into API gateways. So I'll leave you with this question to chew on. Let's say your next project has, I don't know, just 5 microservices. Do you really need an API gateway? Is the complexity worth it yet? It's a classic engineering trade-off, and there's no single right answer, something every good architect has to think about. Thanks for joining me.